It's also my first time presenting to people that I don't know about, so I apologize in advance. The topic today is introduction to cryptocurrencies, and we'll talk a little bit about Canada Ecoin as well as sort of a use case. So this is me. You can find me on keybase.io, which I'm not sure if you guys know about what it is. You need a presentation on it, so maybe next time I'll do a presentation on that. But it's very much a key exchange program, platform for individuals, and it's worth checking out. So, has anybody here used Bitcoin before? One? Well, Marco. Does anybody have Bitcoin in their pocket? Yes, he does. There you go. How many people here have never heard of Bitcoin before? Nobody. Sweet. How many people here know how Bitcoin works? A little bit? Okay. Well, let's talk about that then. Again, I'll apologize for my crappy presentation style because I'm really a greenhorn. So how Bitcoin works. Does everybody here know how a bank works? Where you basically go to the bank and they write down on their book how much money is in your account. And that's basically the main function of this bank, is to keep track of a ledger, right? Is that easy to understand sort of thing? So imagine the opposite. And this is kind of what crypto coins is, where instead of everybody lining up at one spot to access this ledger, everybody actually gets to have a copy of the ledger. So let's say all of us were the Bitcoin network, and each of us were a node. And me and Marco did a transaction together. Let's say I sent him 5 Bitcoins. Everybody here would update their ledger with that record. So we all actually would have the exact same ledger. So if Marco decided to hack into his ledger and give himself an extra 1,000,000 coins, we could all see that that's not real. And we would say to Marco, delete your ledger, let's start from scratch. And we would each sort of hand him one transaction at a time to get him to present day. And that's kind of what this is. It's a database that is stretched through time. And that's what gives us some really curious capabilities. Do you guys understand when I say that? Like, everybody gets to have their own secure copy of this ledger. Everybody gets to be on the same page all the time. You have a question?
If everybody's got a copy of the ledger, over time that's going to be huge.
Yes, very. Yeah, so, I mean, that's part of the math about it.
Like you eventually say, after this point, don't worry about it?
Well, in theory, that'd be nice if we could say that. But there's no real method of doing so that everybody kind of likes and is taking it as a standard. One thing about Bitcoins or crypto coins, I'll call them crypto coins. Bitcoin was the first. It came out in 2009, and it was cool. Everybody was gawking at it, like, oh, this is really neat, nice. But then, like you brought up the point, what about everybody's hard drive? It's going to get big. And so people started creating other types of coins with different characteristics to sort of counter different issues with the characteristics, right? Because again, you have this chain that's building, this database that's building on clockwork. You could say, in 25 years, what size is that going to be? And you can pretty well guess a minimum max, right? Bitcoin being the oldest one right now, it's growing at gigabytes a month.
So if somebody's starting with a new wallet, it's got to download a Bitcoin.
Yeah, so when you get involved with Bitcoin, you download the wallet, they call it. And it's new, it's never been used, so as soon as you come online, you start announcing yourself, hey, I'm here, I'm at block 0, or height 0, please fill me in with what's missing. So as a Bitcoin user, you're gonna get, months of this trying to get up to speed on a shady PS, but if you have a good computer, it could take, a week, but it's still a week, and it's still upwards of 60 gigabytes of information for Bitcoin. And Bitcoin itself, the way it works, on clockwork, you have this sort of new entry into the database. So every 10 minutes, there's this new entry, and the maximum size is 1 megabyte, which really doesn't sound like a lot, like a floppy disk, But, add it up, 10 minutes, floppy disk on floppy disk on floppy disk, and it really does add up. And some of these other coins, like Canada Ecoin actually is 30-second block times with the same with the same megabyte cap. So you have this, every 10 minutes there's 20 megabytes of information going into this database. Now, lucky for Canada Ecoin, it's not so popular that it's eating up all this space. In fact, some of the blocks are empty. It's a couple kilobytes of a placeholder sort of thing.
So the advantage doesn't have any data.
What's that?
The advantage of it is it's not popular.
Well, for Canada Ecoin, it's so quick that you don't have to wait 10 minutes for a confirmation. And if the blocks are full, which is in the case of Bitcoin right now, in this 10-minute time span, you might actually have 1.5 megabytes of information trying to get in, so you have this 0.5 megabyte overfill that has to get in, but it's waiting for the train, it's waiting for the next 10 minutes.
So this is a distributed data set.
Yes.
So what updates it every minute?
The peers themselves sort of decide. It's not that it's updated every minute, it's every peer is trying to compute the next step, the next block. It's the whole thing works on this proof of work. So if you can imagine, all of us are mining, and this is what it's called in Bitcoin, where it's the worker trying to push the block along, trying to push the chain along. It's called a blockchain, by the way. We haven't gone to that in my slides, but as the computers are randomly guessing a hash, and that's what they're doing, and they have to guess this hash at a certain difficulty. So what it means is how many zeros can they have in the beginning of it. So it's not so random because they're trying to make it so there's so many zeros in the beginning, so it causes the difficulty to go high, right? Now the blockchain or the database itself wants to have a 10-minute sort of transaction block time. So it's going to mathematically say, well, look at all the people we have the power pointed here. If we wanted to land around 10 minutes, how many zeros do we need in the beginning of the hash? So it's targeting a certain time. And it provided the node or the user, the wallet that gets the correct, gets to yell bingo, so to speak, doesn't violate the rules of the retargeting, then the other peers will accept it as a true block or as an addition to the data set, right? And the whole idea here is each client has a set of rules, and the rules can't be broken, because if I break the rules, you guys will just tell me, okay, start again, you know what I mean? Even if I was able to keep my rules and keep my 1 million coins that I broke, I'd be the only one playing in that data set, because all of you would have rejected it. You know what I mean? And this is the beautiful thing about this distributed technologies, where you don't necessarily have to trust a central figure to update the ledger. We trust each other because we have these rules and we can transparently see everybody and the rules that we're playing with.
So the transactions are public?
Pardon me?
The transactions are public, each one knows the wallet of the other one?
Absolutely. Everybody in the network has a copy of every transaction. Now for you would actually only really keep track of your transactions. You would say right from day one, here's my wallet, and you're kind of looking at it like it's a lotto ticket, where's my money coming in? Now if there's a transaction that has you listed as a receiver of the money, you now have an input that you can write an output for. So as you write to me 10 coins, now I have the ability to re-sign, using that input, I can sign some outputs to the next person. And therefore, it's all sort of self-regulating through the cryptology of this whole thing.
Is there a commission that one pays when one is signing over Bitcoins to a verifying party?
Yes, you pay a transaction fee. And your transaction fee is based on how many kilobytes of information you're putting into this block. Because remember, the block can only hold 1 megabyte. So, let's say, for instance, each one of you gave to me 1 coin. So I have an input from each of you. I have 11 inputs. I have 11 coins, but it's literally 11 $1 bills coming into my wallet. Now, if I wanted to send out that 11, I would have to write the transaction like this. In, out. So all of that is bigger than saying 1 in and 1 out. In the case of 1 in, 1 out, I might not even pay a transaction fee because it's literally a couple bytes. But if I'm mining, and let's say I'm mining a third of a coin every day or two, and after weeks I'm going to have this big transaction. It might cost me, in the case of Bitcoin, $1 even. Because Bitcoin right now, the price is around $1,350 Canadian. And your transaction fee you're paying by the kilobyte is 0.0001 Bitcoins, which is around, I don't know, I want to say 13 cents, but I feel like it's way more when I actually send it from my wallet. A lot of times it's bigger. And the thing is, if everybody, let's say there's a lineup, let's say there's 2 megabytes worth of transactions trying to get into this thing, so there's this backlog building and building. Well, now your transaction fee actually goes up because you're playing a competition game with people. I'm going to say, I'm going to pay more for my transaction to go into the database, and Jimmy as a miner is going to accept me first because he wants more money. So why wouldn't he just take my money rather than somebody who's putting it maybe a smaller value of a transaction fee per kilobyte? Because remember, he can only stuff in a megabyte worth, so he's going to basically take all the transactions, sort them by, most money per kilobyte, and take the top megabyte and try to be the guy who gets that reward, or be the guy who gets to, come up with the math of that works to make that block or that information get appended,
You talk about mining, can you explain that?
Yeah, mining is the process of a computer guessing, just coming up with hashes, like lots of hashes every second, and hopefully one of them would work. And the way the blockchain works, to make it a little more understandable, each 10 minutes, in the case of Bitcoin, you have a block. The block is a 1 megabyte, so you're adding a block on top of a block on top of a block. You know what I mean? And what you're doing is when you create a block, you're referencing the previous block, and you're coming up with the hash that encompasses everything, and you're also referencing the next block. So you can't actually take a block out from the middle and put one in, right? But these blocks are all connected by hashes, right? And by saying, like, let there be 4 zeros on the front of the hash, you're increasing the difficulty. You might have to come up with 1 million hashes before you get that one. Well, you coming up with those 1 million hashes to get that one is you mining, and you being a computer. Not necessarily, it would take you forever, I'm sure. In fact, Bitcoin has a competition mining. It was the first one, so everybody's trying to get it. So everybody runs out and buys computers, attaches it to the network, so the network is more powerful. So less people get less rewards because now there's 20 people, so you're splitting it from 20 people. Well, all of a sudden tomorrow, 20 new people go out and buy these rigs to mine Bitcoins or to join the competition. And now you're getting 1 out of every 40 because there's 40 people. Now years go on, and there's enough energy in Bitcoin to power major cities. Like this is a major energy hub because of the competition factor. It's probably also why the price is so high, because it really does take that amount of money to mine the coins themselves, right? Now I'll tip on a little bit of the reward. When Bitcoin was brand new, they would give rewards of, I think 100, or no, it was 50. I think it started at 50. So after time, instead of just spewing coins out all day forever, they say, well, we're going to put a limit on it. After a certain amount of time, we're going to divide that in half. So it goes from 50 down to 25. And it's called halving. So every certain amount of blocks, it gets cut in half. So there'll only ever be a total of 21 million Bitcoins in circulation ever. And eventually it'll be where you're only getting points of a coin for your reward, because it's limited in that cycle of halving itself.
At this point, then, does the Bitcoins mined pay for the electricity since they're halving and the value is?
I don't know. The problem too is in North America is one thing, but China is actually mining a lot of coins, and the Chinese government doesn't necessarily have to pay for electricity. So
They don't approve of the Bitcoin mining, but they don't have the iron grip over everybody that some seem to think they have. So apparently the Chinese government very strongly frowns on Bitcoin. They like to take control on their currency. But that doesn't, there's all kinds of things going on in the black market in China because that's the way things are.
yeah, and quite honestly, this type of system is really hard to govern.
Yes.
Because you have peers connected in a serverless manner. It's peer-to-peer. It's an end-to-end model, right? And even if you block some ports, it doesn't matter. You just move to a different port.
And what happens if, I don't know anything about it, but my understanding is that if more than 50%, if a group of, an organization of miners controls more than 50% of the blockchain verification, that can pose a real problem because they can pretty much take over the blockchain or something.
Yeah, so imagine, because it's a consensus-based thing, so imagine, let's bring it down, let's just imagine there's 5 people mining. And everybody had the same graphics card, so it was very easy to say it's comparable, right? Let's just assume that's our test case. So what happens is the blockchain or the database itself sort of tunes into those people with the 100 horsepower, so to speak, right? But let's say that all of a sudden Johnny goes out and he buys himself 10 graphics cards. So he has 200 horsepower by himself. And currently the group has 100 horsepower, right? So as soon as Johnny plugs in his 200 horsepower, the network itself is running 300 horsepower. But it's timing itself to run at 100 horsepower. So instead of every 10 minutes to get a block, you're getting a block every 3 minutes, because it's just got that much more power. Now, it will retarget in a certain amount of time. In the case of Bitcoin, every 2016 blocks. But during that time, before it retargets, it's vulnerable to some types of attack. The big one is called the double spend attack, meaning, let's say I send 100 coins to Johnny, and before they clear, I send him 100 coins to Jeff. Well, who's going to get the coins? They both gave me the goods. I'm in my car running away. You know what I mean? And this has been the problem for hundreds of years, the double spend attack. I mean,
Well, for hundreds of years, you can't do that with cash.
well, the cash itself is a double spend attack system. The government just prints and prints and prints. So as you're sitting at home in your house, you have $100 in the bank. Well, that $100's value is compared to what's in circulation total. So as they increase the amount of in circulation, the value of your $100 is actually only $96, and they're doing the double spend behind the smoke and mirrors, which is another problem with the bank. I mean, I don't want to necessarily rag on banks because it worked for a lot of time and we have a lot of good things come out of it, like iPhones and my gears and everything else. But this system is pretty great. I like it. I'm sort of obsessed about it. I wouldn't even say sort of, like the blockchain itself, this idea of having distributed models within our applications really gets me going. I think it's great. I mean, if me and you and you and you can all do a handshake and we all have our keys all set up, why couldn't we talk to each other without a server? And if we found a server, why couldn't we just sign ourselves in anyway with our own security? You can own your own security, and this is the benefit of sort of this peer-to-peer distributed model. Yes?
And one problem, and so I hear you. I mean, what you say is correct. But one problem I see with this model, and I know that like you have a cryptographic identifier as you. You don't identify yourself with personal information.
Right.
But if your identifier gets disclosed, then your whole spending history forever is also disclosed. So there's no ability to have purely anonymous historyless transactions. Like if I put in a coin, if I put a coin into a vending machine and nobody is around to see it, I didn't spend a coin.
Right.
The vending machine acquired a coin, but I didn't spend a coin. Whereas, so you can imagine, I don't know, maybe I'm cheating on my wife, I buy some jewelry from somebody else, or maybe I have some sort of weird hobby that would be objectionable to my company.
Right.
Like I go to protest rallies against my own corporation. Then, if my information gets out, then that opens that up, that everybody can see what I've done.
Yeah, and there's countermeasures for that sort of thing. When you download a Bitcoin wallet or a Canada Ecoin wallet or any of these coins, it generates a new wallet every transaction. So there's only one transaction per wallet, but there is this taint level that you can sort of track through where did it go. And of course, if you have, let's say you posted a wallet on your LinkedIn, well, that information is now open. So if you use that wallet to whatever, right, you've outed yourself to a degree. And
Can people follow the wallet forward?
Well, you can always look at a wallet and say what came in and what went out. So you can see that the wallets that contributed to the value of that wallet in its current state, and then you can see where that money goes to. And there are known wallets, like you could say this is the exchange, or if once you can identify a wallet in a public space, that information's there. You can always sort of scrape that and do what you want.
So they use tumblers to kind of work around that, don't they?
Well, there's a couple ways to do it. Right when you install a Bitcoin wallet, it generates 100 keys right away. And it's very much a private key, public key situation. And they're sort of this random, they kind of pick them out of nowhere. There's no real means to generate other than the prefix, right? So there's more wallets in the Bitcoin network than there's grains of sand on every beach on this planet. There's enough, right? And it's very possible that you kind of generate one and you generate another the same one and you can kind of steal his coins, in theory. But there's just so many different possibilities that chances are it's not going to happen, right? There is something called deterministic wallets. These are my favorite because today I can create a wallet from a root key, master key, and from here I'll determine everything in the future. So today I can write down my backup, and in 20 years from now, I still have all the transactions that has happened in that 20 years from today's backup. So you're actually backing up the future.
I'm assuming that what it is it takes the ledger and the starting point and combines them to recreate the intervening time?
Well, what you do is you create this Bitcoin wallet, you consider that as 0, 0, and you do an elliptical curve from there. And you say all these points from here on in are my wallets. And you can actually create that math of your own in your own applications. There's really no standard to it, but there's a standard bit32.org. You can check that out, bit32.org. But you don't have to stick to that if you're a developer or whatever. Like, if you want to hide your stuff, you could sort of create any math you want and follow the line. The idea is you're creating the math today to leave yourself the breadcrumb trail for the future. And to me, this is really awesome. I mean, all this sort of crypto stuff, Let's Encrypt is pretty awesome. To me, this is the future. You know, it's one thing to say Google Apps, here's my life, here's my songs and my spreadsheets. I mean, I did that for a while. I used Outlook for 10 years too. I mean, don't hate me. You know, but the idea of creating your identity from nothing, nobody's seen it. You didn't ask Hotmail or Google. You came up with this from your own. It's in your own pocket. Nobody's seen it. And you can do business from here. And you can prove yourself from here. You could say, you know, have a signing authority sign for me right here. This is kind of what Keybase does for you, you know. Now you come up, everybody is your own signing authority. If me and you know each other, why wouldn't I trust your certificates? I know you. You know what I mean? It's different than a domain name. It's more about interaction through time. And through time is what I want to sort of emphasize, because the blockchain itself, as soon as it started, as soon as that first spark happened, it grew, you know, through time. And it's a tool that you can use to keep track of things that have that time element through it, you know. Blockchains you can use for almost anything. There's millions of possibilities. Bitcoin's just one of them. I mean, you can use it for your shares of your own business, have your own private chain, mine everything yourself, you know. You can use it for access control in a building. You can use it for endless opportunities here. And in my view, I think a lot of things are going to be rewritten to encompass this self-journalizing, you know, database, which to me is pretty awesome. So let's see where I messed here. Okay, so if you want to learn more about the deterministic wallets, this is basically creating your own ID, your own self-storage. Bip32.org has a nice little calculator on it. So you can kind of see how things work. You can change the account, you can change the different keys that it's hard to explain. I would just check out the site because it'll do a better job of explaining itself. Keybase.io, I want to talk about again. It works well with tonight's presentations because Let's Encrypt is for your website, which Keybase is for you, right? Keybase will actually let you do communications with people that are your friend, you're followed on the site, but it also has actually a file system that they've just come out with recently, I think in the last few weeks, and it'll actually allow you to share encrypted files with people on Twitter who actually haven't signed up yet. I really like Keybase.io. Definitely worth checking out. I'm not sure I have enough time for Canada Ecoin. It's very much like Bitcoin, except the algorithm it uses for doing its work is different, and it's more of an eco-friendly thing. Instead of just having this hashing algorithm sort of guessing all the time, it incorporates a little bit of memory in the job. So it takes it's not just so CPU heavy. There's a little bit of memory in there. It makes it a little bit resistant to having ASICs, which are application-specific integrated circuits. So script also can be merge mineable, which means you can mine Litecoin with Canada Ecoin with one device, many chains. Again, it's more eco-friendly. It's faster. And I'm just going to wrap it up here. I think the time is up anyway for the night, but you can get some more information. There's 3 websites here that are a great place to start. And I would say if you're going to get into cryptocurrencies, spend a good afternoon on YouTube. There's ins and outs that you're sort of going to want to know. You'll learn them eventually. If you don't learn them on day one, you'd rather learn on day one. Especially on how to back up your wallet. There's a story of a guy who had a laptop in the beginning days of Bitcoin. They were worth pennies, maybe a couple for a penny, I don't know. He threw his thing in the garbage. Years later, big bucks, and he's searching the garbage can for his laptop or the landfill, and he never found it. But apparently that laptop's worth millions now, so, you know. One other thing I want to mention is there's a wallet called Coinomi, available in the Google Play Store. This is a universal wallet. It'll actually create a deterministic wallet for you when you first install it. It'll tell you to write these words down. Make sure you write these words down, because that is your backup. And if there's any questions, I can take them.
In the future, can we expect that the banking system will be replaced by cryptocurrencies? If that's the case, then how you assure the privacy? Everybody will know your wealth, yeah? So,
Well, you would expose, it's open to having you expose your wealth. It's not inherent that people know your wealth. If you use the same wallet all the time, if you just kind of printed off a business card and had a wallet on there, always just accepted money on that one, then that's exposure, because everybody who sends money to that wallet will see everybody who's been there already. But again, the software generates a new one every time. So generally when you look at a wallet, it'll have one set of inputs and one set of outputs. Unless it's a website or some corporation who, for whatever reason, want to have the transparency for their users, which, you know, there's certain different practices in that. But for a user, generally speaking, you're creating a new wallet every time you have it in, and then when you spend it. In fact, when you spend it, like let's say you send me 100 coins, and I wanted to send him 50, I'm not just going to send him 50 from my 100. I'm actually going to say, I'm going to take that whole 100, I'm going to send him 50, and I'm going to send myself 50 in a new wallet. A change address, I'm going to give myself change. Because I actually have to send out that whole entire input. I have to make that whole input and output. But that's the point where I would divide it, half for you, half back to me, as change. So it's very interesting stuff. YouTube has lots of information. The blockchain is what you're looking for. And in the future, I wouldn't expect the banks to sort of take this stuff on, but people are using it right now. There's lots of, there's over 1,000 different coins. Canada Ecoin is by far not original at all. What we are is just a bunch of guys who like to work in the space because we find it very interesting. In the future, I would say you're going to have sort of your setup, and you're going to be talking to the bank and probably 5 or 6 or 12 different coins and blockchains for different reasons. So I'm excited to see what happens in the future. I don't know.
Are there still ATMs where you can deposit Bitcoin and get cash, or vice versa?
Yeah, there was one in Guelph on Gordon Currency Exchange. I'm not sure it's there anymore.
No, it's gone.
Yeah.
This one here in the
pub on King has one, but it's 12%. It's crazy. If you want to trade, if you're looking to buy Bitcoin, there's a wallet called Mycelium, which you can download to your phone. It has local traders built right in, so you can find somebody in your area, go and meet them, pay cash. If you meet them 4 or 5 times and like them, you can start doing e-transfers. It's kind of up to you to build the trust with the individual, but you don't have to trust the system because it's trustless. You just don't have to trust it, so you can trust it, right? You still have to worry about users though, because users, man, they mess everything up all the time.
there was in the news that Bitcoin has been hacked and Bitcoin and Ethereum, yeah? They've been hacked and they were talking about forking or something.
There's always a threat of a fork. I don't like forks personally. I think, the rules were set in the beginning and just kind of let them run out, It's kind of like trying to refuel the rocket once it's been launched. You've already set it up, it's been fired off, just kind of let it go. That's my opinion. I don't know if anybody here knows Ethereum, but now there's 2 Ethereums. Maybe one day there'll be 4 or 8, I don't know. Bitcoin's similar. They're talking about changing rules. They're actually introducing something called SegWit, which is a little more advanced. It allows you to take some of that information from that 1 megabyte and put it somewhere else, so you can get an extra 6 to 8% more information on the chain. I think it's great that that it's evolving. There's things being added, changed. There's different teams here. There's camps over there. When they see a problem, they try to solve it. Even maybe you shouldn't solve it, but let's try anyway. I like it because we know more about it. I mean, this is very new stuff. January 3rd, 2009, Bitcoin came into existence, and to me, it's a self-taught thing. There's not really many schools that'll teach you this sort of thing either. So it's good to have the muckery or the mess ups or whatever, or the forks or whatever. Because like I said, it pushes the education forward at the very end. I mean, I don't really expect any change that exists today to exist in 100 years from now. So from here till then, we'll see what happens. But there's always risk
Where's
for
Craig
it.
Wright these days?
I don't know. I haven't seen him in a while.
Did you see the article in London Review of Books about him once he decided to go public and then reneged on the decision, whatever? One of the authors from the UK, Andrew O'Hare, interviewed him extensively for a book, but everything fell through when he decided he was reneging and revoking his claim of authorship of Bitcoin. It was a really fascinating article about Craig Wright and how he got to where he was and how he backed out again and stuff. Fascinating backstory of Bitcoin.
So do you think Craig Wright is Satoshi?
Yeah, it looks like it. He made a pretty convincing case that he was. Very, very convincing case.
What he needs to do is sign something with Satoshi Nakamoto's private key, and that's what he needs to do.
That's what he needs to do.
That's the laptop that don't.
Yeah, that's the most valuable laptop.
Probably.
But the same author did a really lengthy, in-depth expose on Julian Assange. He spent a lot of time at the UK hideout that he was with prior to the embassy. Really brilliant author, worth reading anything he's done as far as I can tell. But he's covered Craig Wright and Julian Assange. There's long-form pieces, really good writing, really good stories, lots of deep investigative story.
I don't think I read the one you're talking about Craig Wright, but I will when I get back to my layer.
Because I don't know what I think of Bitcoin. The concept, really, really good. It was like you said, there's really a huge future for stuff like this. So the guy that wrote it, very clever man. Very clever.
Well, not only that, I mean, he didn't really do anything revolutionary. I mean, there might be people who kill me for saying that, because Bitcoin's revolutionary in the space that it's in. But really, all the pieces existed before that. It is just a different combination of how they were assembled, which to me shows you, I mean, there's evolution where you think there's no evolution, right? The idea of having this distributed database, to me, is everything. I mean, if you can imagine all of us had the same MongoDB instance running, and we all kind of trusted each other. If we didn't, you'd have to have my key anyway. So I could have strangers on board and not care. You know, I mean, you could use blockchain and the distributed model, DEP for instance, with Meteor, to raid the whole world. I mean, you know, raid zero, not raid like bank raid. You know what I mean?
What drives the value of the Bitcoin? It has like an intrinsic value, and then it has a value driven by the market sentiment of volume and how people are feeling when they're trading.
Yeah, I mean, the news feeds off it a bit, but mostly supply and demand, right? You'll hear in the morning, some mornings, somebody got hacked with lots of money. So you see a lot of fluctuations or whatever during that time, but I mean, it's a new thing. So it's not like the stock exchange where you have trillions a day going through it to keep it nice and calm. It's volatile when it comes to the news and stuff, but to me, it's been fairly consistently going up since it was born. I mean, started at zero, now it's at $1,350. So I think it's doing pretty good.
So when hacking happens, it plummets, the price plummets, and then I think it fell to 500 or something.
Yeah, I don't know.
Rebounded.
I would bet that you won't see a $500 Bitcoin anymore. I would bet that. I'm not really a gambler, but I would take that bet. You might see it dip back below 1,000 Canadian, but probably not much below that. I don't know. It's really hard to say. I mean, I'm not a fortune teller. I wish I was.
It's really quiet on the hacks against the exchanges for a couple of years now. And that seemed to drive some of the fluctuation and volatility as well.
Well, you learn things from episodes, right?
Christian, can you define an exchange, how an exchange would fit in?
Yeah, so there's a couple ways to do it. Let's say you have lots of money and developers and you want to be an exchange. You would just connect to 100 different coins with your website, and your database would kind of do the work for you. I mean, when I go to your site to be part of to exchange, I would go into one of your order books, right? Let's say Canada Ecoin versus Bitcoin, and I would just say I'll buy this much Canada Ecoin at this price. You would sort of earmark my money, because I've already sent it to you at that point, for that trade, so I can't sort of trade with it elsewhere. But when somebody else comes in and says, oh, I'll sell at that price, then you have a deal, because you have two people that
So
agree.
it's literally like a currency exchange.
Yeah.
Like the
Well, that's the very
kiosks
definition of a
exchange
market.
US dollars.
Yeah. And there's exchanges out there right now. I want to say OpenLedger.io, but they're peer-to-peer. So we're getting smarter when it comes to these transactions, right? So we have smart contracts now with Ethereum. We've had them with Bitcoin forever too, so nobody really knew how to do it. Where we could meet in the cloud. Literally, there's no man in the middle, right? I'm not necessarily sure exactly how some of these peer-to-peer exchanges work, but that's the idea. You kind of crack the deal, and there's various steps to those transactions that make it safer than just sort of over-the-counter type thing. But again, there's no central authority there, right? Open Bazaar. Anybody here heard of Open Bazaar? Nobody. So it uses distributed hash tables like BitTorrent does to sort of corral the yellow pages, and you can open up a store. As long as your computer's on, I could go through that hash to get to you and to buy whatever wares you might have. And it's sort of all linked with Bitcoin as well. So, I mean, Open Bazaar itself is a Bitcoin marketplace, but it's peer-to-peer, all done on distributed hash tables, which is really awesome. I mean, I don't think anybody uses it. I have a store on there. I don't know. Nobody's ever said anything to me on my store, but it is cool, right? Proof of concept wise, all this stuff is really, really cool. It all has to evolve more, though, for sure. Any other questions? Very good. Well, I'll pass it back to the MC.
What?